Hi students, we have come to the last part of the applications of integration, and that is kinematics. So do get ready a pen and some papers and practice along with me. Let's look at some concepts that are needed. If we let S to represent displacement, B to represent velocity, A to represent acceleration. So to find velocity, we just need to differentiate displacement with respect to time. And to find acceleration, we just need to differentiate velocity with respect to time. Or you find the second derivative of your displacement. So if you look at it the other way around, if you want to find displacement, you just need to integrate velocity with respect to time. And to find velocity, you just need to integrate acceleration with respect to time. Besides this, there are some other important concepts that we need to know, such as if you are told that this displacement is equal to 0, that means the particle is at fixed point O, or it returns to the fixed point O. If you are told that velocity is equal to 0, it means the particle is at instantaneous rest. If you are told that the acceleration is equal to 0, it means the particle moves at a constant velocity. Besides all that we have mentioned, there's another very important concept. If you were to look at the questions shown on the screen, if you have a particle P, it moves in a straight line so that its distance s meters from a fixed point O is given by the equation s equals to 12t minus 3t squared, where your t is between 0 and 4 inclusive, and t is the time in seconds after passing O. And if you're asked to sketch the motion of this particle P, how do you think the motion will look like? So the first point to take note is the distance, or the s meters, it's calculated from the fixed point O. This is very important. So what we're going to do is we're going to substitute t to be 1 second, t to be 0 second, 1 second, 2 seconds, 3 seconds, 4 seconds, and let's calculate the distance. So when t is equal to 0, basically the distance s is equal to 0. T is equal to 1, you will get s equals to 9. If t is 2, you will get 12 times 2 minus 3 times 2 squared, that gives you 12. T equals to 3, you will get s equals to 9. And t equals to 4, you get s equals to 0. So if I'm going to use a diagram to illustrate this motion, this is how it will look like. We start off by having a fixed point O. And when t is 0, of course, s is 0. But when t is 1, the particle would have traveled 9 meters from O. So this is how it looks like. That is when t is equals to 1. When t is 2, you will travel 12 meters, right? So 9 plus 3 will give you 12. That is when t is equals to 2. When t is equals to 3, s is 9. Now remember, you have to measure the distance from the fixed point O. So this is what it means. 9 meters from the fixed point O. That is when your t is equals to 3. So what happened? You see, your particle is actually traveling in this direction. And now we are saying that it's traveling the other way around. So something must have happened to the particle at t equals to 2, right? Yes, sorry, at t equals to 4, it's back to point O. When the displacement is 0, it's back to point O. Right, so back to just now the earlier question. Something must have happened here, right? So what do you think happened there? Yes, the particle has made a reverse direction at t equals to 2. So what does it mean? by saying that the particle has made a reverse direction at t equals to 2. It means that t equals to 2, the velocity of the particle is 0. So it could have hit a wall and then bounce to make a reverse direction. Or someone could have given it an external force, slow down to v equals to 0, external force to make it reverse its direction. So this is what it means. So when you substitute t equals to 2 into your velocity, how do you get the velocity? The velocity is found by differentiating the formula for finding distance. You will get 12 minus 6t. So when you substitute t to be 0, you will see that the velocity at t equals to 2 is 0. So this is a very important concept. So if you look at the diagram carefully, you see that the total distance traveled in the first 2 seconds is 12 meter. The total distance traveled for the first 3 seconds will be 9 plus 3 plus 3. The total distance traveled for the first 4 seconds will be 9 plus 3 plus 3 plus 9. From here to here will be 3 meter. That's how we get 9 plus 3 plus 3, the total distance when t is 3, and 9 plus 3 plus 3 plus 9, the total distance traveled when t is equals to 4. So in summary, what does it mean? It means that before we calculate total distance traveled, we need to take into consideration if the particle is traveling in a straight line or if it has reversed its direction at any given point. So to know whether the particle has reversed its direction at any particular point, then we will need to let velocity equals to 0. For example, in this case here, at the particular time there, if it makes a reverse direction at that particular time, it means the velocity is equal to 0, so it makes a reverse direction. And then at that time again, a second time, if it's reverse its direction, means at the particular time t equals to some value, velocity equals to 0. So this is what it means. Right. So if you have the expression for your velocity, you just let it equals to 0, and you will be able to find the different timing. So this could be at t equals to t1. This could be at t equals to t2, so on and so forth. Right, let's look at these questions here. So we have a cyclist that starts from point A and travels in a straight line until it comes to rest at the point B. So during the motion, the velocity is given by v equals to 6t minus half t squared. T is the time in seconds after leaving A. So for part A, we're asked to find the time taken for the cyclist to travel from A to B. For part B is to find the distance AB, and part C is to find the acceleration of the cyclist when t equals to 8. Alright. So when the question says that the particle comes to rest at a point B, this is a rather important concept. What does it mean? So we address this question later on. So first, let's use a line to represent the motion of the particle. We have 2 points A and B. Yes, when it says comes to rest at point B, it means at point B, the velocity is equal to 0. So we're going to let 6t minus half t squared equals to 0. And you can factorize t out. So t can be 0, or 6 minus half t equals to 0. From there, you can get t equals to 12. So t is 0, it's when it is at point A. So therefore, the time taken for the cyclist to travel from A to B will be 12 seconds. Let's look at part B to find the distance AB. So we understand that the particle travel, and then stop at part B, where velocity is equal to 0. Right, so to find the distance AB means I need to have the expression for the displacement. So to find displacement, it means that we need to integrate velocity respect to time. And because from 0 to 12, the particle travel in a straight line, it's only at point B the velocity is equal to 0. So from point A to point B, there's no turning point at all. So therefore, I can actually integrate velocity with taking the lower limits to be 0, upper limits to be 12. So that will by doing that, it actually helps us to avoid having to find the constant c. Otherwise, you will have to integrate v respect to time as an indefinite integral and then plus c, right? And then substitute in when t is 0, s is 0 to find the constant c. But if you're going to integrate velocity respect to time from 0 to 12, then you don't really have to find you're actually doing definite integral. So you do a way of having to find the constant c. So the total distance AB is 144 meter. Okay, so that is part B. So for part C is relatively easy. So acceleration is actually the rate of change of velocity with time. So you just need to differentiate V to get acceleration. Which, if you differentiate 6t, you get 6. Differentiate t squared, you get 2t. So you end up getting 6 minus t for acceleration. And you substitute t to be 8. So the acceleration will be negative 2 meter per second squared. So this is how you do this question. Right, let's look at the next question. The next question involved a train, and this particular train traveled on the straight track. So it passes two signal, okay, signal X with speed 30 meter per second. And then 20 seconds later passes signal Y, this time having speed 10 meter per second. So during the journey from X to Y, the acceleration is given to be A equals to KT minus 2. So K is a constant and T seconds is the time after passing X. So there are two parts. Part I is to show that K equals to 0.1. And part 2 is to find the distance between signals X and Y. So we're going to have a diagram to represent the motion of this train. Right, so the 2 points there, X and Y. So at X, the speed is 30 meter per second. Right, 20 seconds later at Y, the speed is 10 meter per second. Okay, so we're given the acceleration. Right, so how do we, so we're given the speed and then the acceleration. So what is the concept involved here? That is, I need to find the expression for the velocity, right? So to get the expression for the velocity means I need to integrate the acceleration respect to time. All right, so I need to integrate kt minus 2. So integrate kt, I'll get kt squared over 2. And integrate 2, I'll get 2t. So the expression for the velocity will be kt squared over 2 minus 2t plus c. Because we're dealing with indefinite integral now. So I need to find this constant c, which is very important because a lot of students actually forget that we're dealing with indefinite integral and you forget to add the c. So to find the c, we need to make fill in the information that we're given. The information we're given is when t is 0, the time taken, the speed is 30 meter. So we're going to substitute t to be 0, velocity to be 30 meter per second. And from there, you can find the values for the constant c to be 30. Right. So you realize that there are actually two unknowns there. All right. You have k being unknown, c is also unknown. So when substitute t to be 0, velocity to be 30 meter per second, right, that will help you to find the constant c. However, to find the constant k, you need to substitute t equals to 20. So at t equals to 20 seconds, the velocity is 10 meter per second. So you substitute into your kt squared over 2 minus 2t plus 30 equals to 10. And from there, you can show that k is equal to 0.1. So that's part I. So for part 2, we're supposed to find the distance between signal x and y. So to find the distance means I need to find the expressions for the displacement, which means I need to integrate v respect to time. So the expressions that we have gotten for the velocity earlier on, we found k to be 0.1 divided by 2. 0.1 divided by 2 will give you 1 over 20. So that we'll get 1 over 20 t squared minus 2t plus 30. So we're going to integrate that. Right, and we need to find the constant c again. So we need to sub in the values for t. So at this juncture here, all right, we will have to assume that when you actually start from signal x. So when t is 0, there's no distance traveled at all. So t equals to 0, s is equal to 0. So therefore, you will find that your constant c is also 0. So hence, the expressions to find your displacement will be 1 over 60 t cubed minus t squared plus 30t. And then you sub in the distance between signal x and y takes 20 seconds. So you sub t to be 20. And from there, you calculate the total distance traveled will be 333 and 1/3 meter. Right, let's look at the next question. So the next questions involve a particle travels in a straight line. So t second after leaving a fixed point O, the velocity is given to be 12 over bracket t plus 1 close bracket to the power of 2 minus 3. So find the expressions for the acceleration of the particle in terms of t. Right, so acceleration is the rate of change of velocity respect to time. So I need to find dv over dt. Which means I will need to express this as a negative index. So that will give me 12 bracket t plus 1 close bracket to power negative 2. So we need to differentiate it to get the acceleration. So here you see that I would have to, if you have forgotten how to do differentiation, you have to look at the earlier videos. I take it as you are able to do the differentiation. So I'm moving on a little bit faster. So you differentiate 12 bracket t plus 1 to the power negative 2. You just bring the negative 2 to the front. So negative 2 times 12 gives you negative 24. The power minus 1. And then the 1, because you need to differentiate whatever inside the bracket. Differentiate t plus 1 gives you 1. Then, of course, differentiate 3 gives you 0. Okay, so that is your acceleration. Okay, so that is what you're supposed to find in part I. So for part 2, we asked to find the distance traveled by the particle before it comes to instantaneous rest. So what does it mean by instantaneous rest? When it says comes to instantaneous rest, means velocity equals to 0. Right. So again, we need to find the expression for the distance. So the expressions for the finding to the distance, you need to integrate with respect to time. Which means you need to integrate 12 bracket t plus 1 cross bracket to the power of negative 2 minus 3. You need to integrate that. Right. So again, we need to find the unknown constant c. Right. So we will have to assume that t equals to 0. No distance is being traveled. So we start from fixed point O. So t equals to 0, s is equals to 0. So from there, you'll find that your c is not 0. When you substitute your s to be 0, you would have 0 equals negative 12 over 1 minus 3 times 0 is 0, then plus c. So from there, you will see that c is equals to 12. So do not assume all the time that t is 0, s is 0, constant is 0. No. In this case here, you'll see that no. Because of the expression given for you, the expression given to you, it's not the same as what you're given earlier on. So it does not mean all the time t0, s0, c equals to 0. Okay, here c is equals to 12. So therefore, the expression to find your displacement would be negative 12 over t plus 1 minus 3t plus 12. And yes, when the particular come to instantaneous rest means velocity equals to 0. So I need to let velocity equals to 0. Why do I let it equals to 0? Because I need to find the times, okay, what time, how long does the particle takes before it come to rest? Okay, so that's when I need to let velocity equals to 0. Right, so t can be 1 or negative 3. So how do you get t can be 1 or negative 3? Okay, because from here, t plus 1 can be positive 2 or negative 2, right? So t plus 1, if it's t plus 1 equals to 2, then t can be 1 or t can be negative 3, because minus 2 minus 1 is negative 3. But of course, t must be greater or equal than 0. So we reject t equals to negative 3. So it take 1 second for the particle to be at rest. So you substitute t equals to 1 into your this distance formula, and you find that t equals to 1 will give you distance traveled to be 3 meters. Right, let's look at the next questions. So for the next questions, we have two particles, P and Q. So Q leaves a point, both of them leaves a point O at the same time and travel in the same direction along the same straight line. So particle P starts with a velocity of 9 meters per second and moves with a constant accelerations of 1.5 meters per second squared. So particle Q starts from rest. That means velocity equals to 0 and moves with an acceleration of a meter per second squared. We're given the acceleration to be a equals to 1 plus t over 2. And t is the seconds in time since leaving O. So for part I, we asked to find the velocity of each particle in terms of t. So that is rather manageable. And part 2, the distance traveled by each particle in terms of t. Right, so the important thing to take note is when you sketch the motions of these two particles, we need to know whether if we're traveling from on the right side of the point O or on the left. Okay, what do I mean by that? It means that if this is your fixed point O, if the velocity is positive, because velocity is a vector, so a vector can have a magnitude and direction. So if a velocity is positive, then it will go this direction. If your velocity is negative, then it will go this direction. But since we are told that both of the velocity, one is 0, one is 9 meters per second, then we understand that the particle is actually going in the direction indicated. All right, so let's see how we do it. All right, so we know that since you're given, okay, so the whole concepts in this kinematics is that you that you need to know the definitions of acceleration. Acceleration is the rate of change of velocity with respect to time, right? So to find velocity, we will need to integrate your acceleration. So all these concepts can be found in the first two slides. So you can just refer to it. Right, so here for part I, we will need to integrate a respect to t. All right, because now we are having two particles P and Q, right? So it's good that we have a heading, right? The heading. So for particular P, can have a heading. So underneath a heading, we can have velocity and acceleration. Another way of doing it is you just annotate it like this P. This velocity represents the velocity for particular P, and A is the acceleration meant for particle P. So this is one way to differentiate between the two particles. All right, so we're going to, yes, so we have a Q, right? So we do the, so that is VQ, that is AQ. Okay, so what's the next step? Right, so we need to integrate. So for particular P, we need to find velocity BP. Right, so we need to integrate A respect to time. So that will give us 1.5 T plus C. Okay, integrate 1.5, get 1.5 T. Right, so remember to put a plus C there, which is important because we are dealing with indefinite integral now. Okay, so we need to find this constant C. That is where the first piece of information comes in. The first piece of information says that the velocity is 9 meters per second when T is equal to 0. Right, so you substitute inside your the expressions for the velocity P, and you will find that the constant is 9. So therefore, your velocity P is given to be 1.5 T plus 9. All right, so let's move on to find the velocity for particle Q. Okay, so there are two ways of doing it. Right, I've just demonstrated to you. You can actually put two heading, one for P, one for Q. Actually, for me, I'll prefer to do it that way. One under P, one under Q. Rather than having to write V and then subscript, yeah, subscript P, the kind of thing. So for particle Q, right, we need to integrate 1 plus half T. Integrate 1, you get T. Right, integrate T, get T squared over 2 times half. Again, you need a constant C there. And we are told that the initial velocity is 0 when time is equal to 0. Right, so you substitute inside there and you will see that your constant C is 0. So this finding this constant C is very important, remember that, okay, because we're actually dealing with indefinite integral, right? And then so you get the expressions for the velocity for particle Q. So that is part I. All right, so now let's look at part 2. So for part 2, we need to find the distance traveled by each particle. Right, so the concept involved here is we need to find the expression for the displacement. So we understand that the rate of change of the displacement with respect to time is velocity. So in order to get your expression for the displacement, I will need to integrate velocity. Okay, so I need to integrate 1.5t plus 9 for particle p. So that will give me 1.5t squared over 2 plus 9t plus constant c. All right. So for particle p, because it starts from rest, so we are saying that when t is 0, there's no distance traveled at all. It starts from the initial position. So therefore, when you substitute your t to be 0, s to be 0, you'll get c equals to 0. Okay, so in terms, all right, so that's it. That's for particle p. So for particle q, we do the same. We integrate t plus 1/4 t squared. Right, so you will end up getting, yes, t squared over 2 plus 1/4 times t cubed over 3 plus c. All right, again here, because they all start from the point O, so we're all saying that at t equals to 0, no distance has been traveled at all, so s is equal to 0. So you get c equals to 0. Yeah, so that's how we find the expression, okay, for the distance traveled in terms of t. So s represents the formula to find the distance traveled. Right, so let's look at the next two parts of the questions. This question is rather long, so I actually divided it into two different slides. So the earlier slides we do part 1 and 2. So this current slides we're doing part 3 and part 4. So for part 3, we're asked to find the distance from O at which Q will collapse with P. So what's the concept involved here? When Q collides with P, what does it mean? Right, so when Q collides with P means the distance traveled by both particles will have to be the same, because they're all traveling. You see, they're all traveling from the same point, O, right? So in order for them to collide with each other, then the distance traveled by both of them will have to be the same. So we are going to equate the expressions we found in part 2. The distance traveled for particle P equals to the expressions that we found for particle Q. Okay, so from there, you simplify it, bring everything to the left hand side, and half t squared minus 3/4 t squared will give you negative 1/4 t squared. So this is a simple algebraic manipulation. I expect that you should be able to manage it. All right, and you see that we have a common factor t. We can just put it out. Oh, okay. I prefer to make it all as non-fraction, so we just multiply by 12 throughout. Multiply by 12 throughout, so you get negative 3 squared minus 108t plus t cubed. Factorize of t out. And then you can still factorize t squared minus 3t minus 108. So we are saying t can be 0, t can be 12, or t can be negative 9. Right. So obviously t equals to 0 is when they first meet each other. P and Q meet each other. T equals to negative 9 is not applicable because we understand that for time it must be either greater or equal than 0. So we need to reject the answer. So the only possible answer is t equals to 12. So they each of them travel for 12 seconds and then they will collapse with one another. So this is what it means. So of course my diagram is not correct. If you're traveling side by side, and then of course you can't collapse. So the only thing I can think of is probably P will travel in this direction, and then Q will be in this direction, and then they just meet here at t equals to 12. Right? It is what it means. If you're traveling parallel to each other, of course they will never meet up. They will never collapse. So they need to be traveled at angle to each other. All right, so that is part 3. We're not done yet. So we need to find the distance from O. Okay, so now we know that t is equal to 12. T equals to 12 is the time where they meet. You can just substitute into the expression for particle P or expression for particle Q. Doesn't matter, because they will have the same distance. That's how they meet. Right, so the distance traveled of each particle from O will be 260 meter. So here I actually substitute into the expressions for particle cube. Sorry, not particle, yeah, particle cube, correct. No, sorry, particle P. Okay, particle P. All right, so let's look at part 4 now. The speed of each particle at the point of collision. Okay, so that is easy also, because once we know the timing, which is t equals to 12, we can just substitute into your individual expression we found for the velocity. Okay. Right, so this is a rather long assignment, all right, and you see that most of the questions, the concepts are similar. What do I mean by similar? Similar means, for example, if you're given acceleration, you need to integrate it to find velocity. And if you're given velocity, you need to integrate it to find displacement. Or if you're given displacement, you need to differentiate it to find velocity. Given velocity, you need to differentiate it to find acceleration. So the context is more or less the same. The only thing given is the expressions given. It could be in terms of trigo function, it can be exponential functions, or it can be just normal algebraic functions. Okay, so they actually test you on how good you are in your integrations and differentiation of these different type of functions given. So for example, if you look at question 5, right, you're given an exponential function, right, and you ask to find the velocity. So the concept here is you need to differentiate. Velocity is the rate of change of displacement with respect to time, so you need to find ds over dt. So that will test you on the skill of how good you are differentiating exponential function. Okay, so when you differentiate exponential function, it's very easy. If you were to recall, if you're given like y equals to e to the power ax plus b, differentiate it is whatever you have is just whatever you see, just write it down. Then times differentiate the power, so which is a. So when you differentiate 1, of course you get 0. So differentiate this guy, the negative is still there, so it will be just e to the power negative t over 10 times you differentiate the power, which is negative 1 over 10. So that explains how I get this step here. Okay, and then of course the next one is to test on how good you are with your algebraic manipulation, the skill of how you manipulate algebra. So of course you differentiate 16t, you get 16 lah. So that explains how I get 16 here. So you multiply them, 400 times negative 1 over 10 gives you 40, e to the power negative 10 minus 16. So that's the expression for velocity. So for part 2, okay, you asked to find the acceleration. So to get the acceleration means we need to differentiate the velocity. So again, it tests you on how good you are in differentiating exponential functions. Okay, and that's it for this question. Okay, so that's it is not for that's it for the whole questions. It's actually that's it for the first 2 parts only. This question is rather long and stinky. There's a part 3, 4, 5. Okay, so for part 3, we asked to find the velocity of the motorcycle at A. Right, so if you read the questions again, we have this motorcycle. It travels at it passes a point A. That means it's already traveling, and then there's a point A and it passes it. So the time taken, the time taken starts from point A. That means at point A we let t equal to 0. Okay, before that we don't care. So the time, if you look at what is written here, it says that the t second after passing A. So your time starts from after passing A. All right. So find the velocity of the motorcycle at A. That is when t is equal to 0. Oh, it's not at point A. It's at point A. Okay, at point A, t equals to 0. So you substitute t equals to 0 into the expressions we found for the velocity, and you get 24 meters per second. So that's part 3. So it's relatively easy. That's why it's only 1 mark. All right, so for part 4, we asked to find the time taken for the journey from A to B to show that it's 9.163 seconds. So from the questions, look at what is given here. It says that the motorcycle will pass through A, and after that come to rest at point B. So what's the concept here? When you say come to rest, what's the concept here? Yes, it means V is equal to 0. So electron velocity equals to 0. This is solving exponential equation. So again, you see all these previous concepts, you need to have a good hands on it. Solving trigo equations, solving exponential functions, that kind of thing. Right, so in this case here, we will have to make e to the power negative 10 over e to the power negative t over 10 the subject. Bring ln to both sides, apply the power law. Right, this you apply the power law to take this guy down to the front, and ln e is log base e that gives you 1. And from there, you show that yes, t is approximately 9.163 seconds. Okay, so that's part 4. So part 5, we need to find the average speed. So to find average speed means we need to find the total distance traveled. Okay, total distance traveled. And here we're very lucky. Why we're very lucky? Because A to B, there's no other turning points at all. That means this motorcycle actually traveled in the straight road all the way from A to B. Only at B then it slow down. Only at B then it stop. At B is when velocity goes to 0. So therefore, we can just simply substitute t equals to 9.163 into the expression given. The expression given is this one here. The distance traveled, this substitute t to be 9.163, and okay, use your calculator wisely, carefully, and you will be able to get 93.393 and put it to, oh, we need to find average speed. So we're going to use that total distance divided by total time. So the answer will be 10.2 meters per second. Right, so let's look at the next question. So next question again involving the exponential functions. All right, now we have a particle travel in a straight line, passes through a fixed point O with a speed of 8 meters per second. And then the acceleration is given to be A equals to negative e to the power negative 0.1 t. So the particle comes to instantaneous rest at point P. Right, so the concept here that you need to take note is, what does it mean when you say comes to instantaneous rest? Yes, that is when the velocity is equal to 0. Okay, so for part I, we need to show that the particle reaches P when t is 10 ln 5. Okay. So we're given the accelerations. Right, so we need to find the velocity. So we need to integrate acceleration. So this one will test you on how good you are integrating exponential function. So if you were to recall to integrate exponential function, it will give you e to the power ax plus b, then over differentiation of your power, differentiate ax plus b, it's a, then plus constant c. Okay, so you integrate e to the power negative 0.1 t, you will get, of course the negative will still be there, will be e to the power negative 0.1 t divided by negative 0.1 plus constant c. Okay, so we need to find this constant c. So we will have to, it says passes through a fixed point with a speed of 8 meters per second. So that is when t is 0, your v is 8 meters per second. So you substitute into it, and your c is negative 2. All right, so in this, so do not always assume that when t is 0, v is something, and then your constant c is 0. It does not work at all, especially for this exponential function. Why? Because e to the power of 0 here, okay, you have to be very careful. Do not assume e to the power of 0 is 1. So therefore, your constant c here is negative 2 and not 0. All right, okay, so we need to show the particle reaches P at t equals to 10 ln 5. So when it reaches P, it's when the velocity is equal to 0. Right. Divide by 10 on both sides. And then bring ln to both sides. So you see, these questions, it don't just involve the concepts of kinematics is also involved on how well you are with your logarithmic laws, how well you are on managing exponential functions and solving exponential equations. Right, so here, this one we apply your the quotient law. If you have ln bracket a over b, that gives you ln a minus ln b. So that gives you ln 1 minus ln 5, and ln 1 is 0. So you get negative 0.1 t equals to negative ln 5, because ln 1 is 0. So 0.1 t will be ln 5. So t will be ln 5 divided by 0.1. That gives you 10 ln 5, which is what you asked to show in part I, and that's 6 marks. Alright, let's look at the next two parts, part 2 and part 3. Right, so part 2, we asked to calculate the distance OP, which means I will need to integrate velocity respect to time. Okay, so you integrate e to the power negative 0.1 t, you get e to the power negative 0.1 t over negative 0.1. Because when you differentiate negative 0.1 t, you get negative 0.1. And not to forget plus c. Alright, so here we need to find a constant c, right? So we are saying that the particular at point 0, t is 0. So we're saying that the distance given will start from there. So when t is 0, s is equal to 0. Right, so again, be careful because e to the power of 0 is 1. So do not assume c is 0. Okay, e to the power of 0 is 1. So you have 0 equals to negative 100 plus c. So c is 100. Okay, here, this step here. So 0 equals to negative 100 e to the power of 0. Okay, when you substitute t to be 0, negative 0.1 times 0 gives you 0. Of course, negative 2 times 0 will be 0 lah. So plus c. So c will be 100 e to the power of 0. E to the power of 0 is 1. So that will be 100 times 1. So that explains why I get c equals to 100. Okay, right. So we need to sub in the time. Okay, the distance OP. How long does it take to reach point P? We calculated the time earlier on, right? Yes, 10 ln 5. So we substitute inside there. And use your calculator wisely as in carefully, and do it twice. Usually, if you're using calculator to work out something so huge, right, do it 2 times and make sure both times you get the same answer, and that will be your answer. If both times you don't get the same answer, then you do it a third time. Right, let's look at the last part of this question 6. The last part of this question 6, we are asked to show that the particle is again at O at some instant during the 50th seconds after passing through O. So what the question is saying is that the particle, okay, this is point O, so the particle will travel, and then after that it must have made a U-turn. It must have reversed the direction, then come back here. Okay, so something like this. Must have made a reverse direction. Okay, and then after that it passed through O. So we want to calculate like at what time the particle actually passes through O. It's just that, you know, someone asks you, you know, when do you see your friend? Oh, you see, okay, I saw my friend at t equals to at 12:30. I saw my friend at 12:30 at the, you know, traffic junction or something like that. Or I see my friend at 11:30 at the bus stop. So this question is something like that. It wants to show that the particle is back again at O. It's back again. No, it's back at O. Okay, during the 50th seconds, somewhere there. Okay, so how do you go about doing it? So we already have the formula to calculate distance, right? We already have a formula to calculate distance. So we're going to substitute t equals to 50 seconds and see what is the distance, what is the displacement. The displacement when t is 50 seconds. right? So you substitute t to be 50, and we found that this, okay, the difference between this displacement and distance is distance has no direction, displacement have. So when you have a negative 0.674, it means that the displacement is on the left side of your fixed point O. So we're going to substitute t equals to 49, and you get a positive displacement. So that is on the right hand side of your fixed point O. All right, so if we're going to use a diagram to illustrate for you, okay, we understand that when v is equal to 0, t is 10 ln 5. So it's that at that juncture where it makes a reverse direction. Okay, it makes a reverse direction. Okay, so when t is 50 seconds, you see that this is negative. Okay, your displacement is always from your fixed point O. Okay, your displacement is always from a fixed point O. That means your 0.674, where is it? Where is your 0.674? Yes, that is your 0.674. And then where is your 1.256? Yeah, that is your 1.256. Okay, so therefore, so can you see that it's somewhere, okay, it's between 49, it's actually after 49, it's somewhere at the 50th second that you see that the particle zoom past O again. Okay, so you can actually use a diagram to explain, okay, that some instance during the 50th second, you can see the particle zoom past O, fixed point O again. Not again, zoom past fixed point O. Yeah, again, correct. Right, let's look at the last questions of the this video. All right, so don't give up, don't give up. We're coming to the end already. We're ending it very soon. So in this question here, we have a dot on the computer screen. So the dot can move left or right lah. Can move left or right. So the distance given by the displacement, okay, the displacement given is equals to t cubed minus 6t squared plus 9t. So find the values of t at which the dot is instantaneously at rest. So when it's instantaneous at rest, it means it's when the velocity is equal to 0. So we need to find the expression for the velocity. So we need to differentiate your displacement, which is the s over dt, and then let it equal to 0. So you divide by 3 throughout to get t squared minus 4t plus 3 equals to 0. Factorize it. Okay, so you have two timing. When you have a turning point, t is 1 or t equals to 3. So that's part I. So for part 2 is when it first comes to instantaneous at rest. So there are two timing that it comes to instantaneous at rest, t equals to 1 or t equals to 3. So t equals to 1 is the first one when they come to at rest. So we need to differentiate velocity again to find acceleration. Then substitute t equals to 1. And that's the answer. Right, so for part 3, we're asked to explain clearly why the total distance traveled by the dot in the interval t equals to 0 to t equals to 4 is not obtained by finding the value of s when t equals to 4. What the question is saying is that, can I just simply substitute t equals to 4 into this expression? Can I just simply substitute t equals to 4 here and say that the total distance traveled is blah blah blah? Can we say that? So the answer is no. Okay, because when we substitute, okay, the explanation is on the screen there. I'm just going to read it out. Because when you substitute t equals to 4 into the expression to find your displacement, we're assuming that there's no turning point for the dot. We're assuming that this dot actually travels in a straight line. Okay, but when we let velocity equals to 0, right, in part 2, no, in part I, when you let velocity equals to 0, we find that there are actually two turning points. That is when t equals to 1, it makes a turn, and then another one at t equals to 3. So hence the total distance cannot be found just by substituting t equals to 4 into the expressions for displacement. Okay, so for part 4, then we asked to find the total distance. So part 3 is just a warning to you. Okay, it's just a warning to you and say, hey, you can't do that, okay? So part 4 is, so if you can't do that, then how are we going to find the total distance traveled? So we need to have a diagram. I'm going to show using a diagram. So we start with a fixed point O. So at t equals to 1, when you substitute t equals to 1, the displacement is 4. So the 4 cm is calculated from point O. So where is it? Yes, so that is your 4 centimeter. So it makes a reverse direction. Okay, it makes a reverse direction. So we substitute t equals to 3, the displacement is 0. So this is how it looks like. Right, it make a reverse direction and then go back to point O. Because when t equals to 0, velocity is 0, displacement is 0. Displacement 0 means it go back to your original point O. Okay, so at t equals to 4, what happened? Displacement is 4. So it make a U-turn and go back to the point. Okay, so this diagram illustrates the motions of the computer dot. So you see that the distance traveled, all these are the same, 4 centimeter, 4 centimeter, 4 centimeter. So the total distance traveled will be 12. How you get 12? So the total distance traveled will be this here, 4 centimeter, right? Make a reverse direction, travel again another 4 centimeter. Make a reverse direction, another 4 centimeter. So when t is equal to 4 seconds, all right, the total distance traveled, it's 4 plus 4 plus 4, give you 12 centimeter. And you see that when you substitute t to be 4 into your expression for displacement, you don't get 12. You don't get 12 at all. You can just do it. (64 minus 6) 4 squared is 16 plus 9 times 4. Okay, you can use a calculator to work that out. Right, you will get 4 centimeter, which the answer is wrong. Okay, because you didn't take into consideration the turning point. So the correct one is the one I've just explained to you how to find. Okay, so that ends the video. Right, happy learning.